Howdy, my name is Mason Mueller, and this is my submission for the CHEM 117 end of semester project. So my project is going to be about how we can determine the signs of the thermodynamic properties of a chemical reaction. I'm going to be using the reaction of baking soda and vinegar as my simple reaction. It's a very simple reaction. Everyone has watched it happen. Most everyone has actually done it. So it is a reaction that everyone should be familiar with. So, in order to find the signs of the thermodynamic properties, we have to watch the reaction happen and observe several things about it. So let's watch that reaction real quick. Alright, so we have about 2 teaspoons of baking soda in there, and we're going to pour in some vinegar, see what happens.
Now that's action.
That is quite the action.
Okay, here.
Now we're going to take some temperatures. I've got this laser temperature finder that says 78.
66.
Yes, So, here's how you would perform these calculations for any reaction, as long as you can observe it and observe the change in temperature. So, if you have the reaction happening, you want to observe 2 main things, and that is the spontaneity and the change in temperature. If the change in temperature is negative, as in it cools down, that means that it is endothermic, it's absorbing energy, and that means your net enthalpy change is going to be positive. If your reaction is heating up, that means it's releasing energy, that means it's exothermic, that means your change in enthalpy is going to be negative. So, given your change in enthalpy and your spontaneity, you can go to the Gibbs free energy sign table and determine the change in entropy of your reaction. Or, conversely, you could look up the chemical formula for your reaction. In our case, baking soda and vinegar. It's just a simple Google search and you will find it out. And with this, you can look at it, and if you want to do math, you can, but typically just looking at it, you can figure out, hey, this has probably got a positive or negative entropy change.
From the demonstration, we observed 2 crucial things. First, the reaction cooled down, and second, the reaction was spontaneous. Going from what I said earlier, this means that the enthalpy change was positive as the reaction cooled down, making it endothermic. Further, we know this reaction is spontaneous, thus we can go to the Gibbs free energy formula and determine that the entropy change must be positive. Now you've learned how to determine the signs of the thermodynamic properties of a reaction simply by observing it. Thank you for watching. Goodbye.